There is a feeling I get sometimes when I walk along the shores of the Atlantic near my home in Massachusetts. You look out at the horizon where the gray water meets the gray sky, and you realize that what you can see is only a tiny fraction of what is out there. For centuries, humanity stood on the shore of the cosmic ocean, picking up seashells, planets, asteroids, comets, and assuming that these familiar shapes were the only things the ocean had to offer. We told ourselves that the universe was barren, that we were the only eyes looking back at the stars, and that any visitor entering our solar system would look exactly like the rocks we find in our own backyard. But nature, as I have learned throughout my career, has a way of humbling us. It does not care about our assumptions, it does not care about our textbooks. Today, I need to talk to you about something that has fundamentally shifted the ground beneath our feet. We are looking at a new visitor, an object cataloged as 3I Atlas. When we first spotted it, the scientific community breathed a sigh of relief. Ah, they said, it's just a comet. It's familiar. It's safe. But as we have peeled back the layers of data from the James Webb Space Telescope, that safety has evaporated. We are not looking at a comet. We are not looking at a simple asteroid. We are looking at something so massive, so chemically complex, and so dynamically strange that it forces us to ask the question I have been asking for years. Is this a message in a bottle? Or is it the bottle itself, washed up from a civilization that disappeared long before the sun was born? Let me take you back to the moment the data changed everything. As a scientist, you live for the moment when your expectations are shattered. Most people think science is about confirming what we know. It is not. It is about finding the anomaly that proves we were wrong. When 3I Atlas was first detected by ground-based telescopes, it was a dim point of light. The assumption was automatic. It's a rogue rock ejected from a star system tumbling through the dark. We expected it to be small, perhaps a few 100 feet across, similar to the objects we've seen before. But then we pointed the James Webb Space Telescope at it. You must understand, the Webb telescope doesn't just see light, it sees heat. It sees the thermal fingerprint of the universe. When the infrared data came back, the room went silent. The object wasn't small, it wasn't a few 100 feet wide. Based on its thermal emissions and its albedo, the amount of light it reflects, we realized we were staring at a behemoth, 3I. Atlas is roughly the size of the island of Manhattan, perhaps even larger, stretching hundreds of miles across. This is not a pebble. This is a mountain floating in the void. Now, why does size matter? In the standard model of planetary formation, small rocks get kicked out of star systems all the time. It's like dust blowing off a construction site. But to eject an object the size of a dwarf planet, to kick a moon-sized object out of the gravitational grip of a star requires an event of catastrophic violence. We are talking about the kind of energy released when binary stars tear each other apart, or when giant planets migrate and shatter everything in their path. But here is where the story gets truly interesting and, frankly, a little terrifying. If this were a natural object, a chunk of a destroyed planet, we would expect it to look like a piece of cosmic shrapnel. It should be jagged, irregular, a mess of ice and rock. But the light curve, the graph we make to track its brightness as it rotates, is strange. It suggests a structure that is strikingly coherent. And when we looked at the surface composition using spectroscopy, we didn't just see water ice. We saw a complex cocktail of organic molecules, polycyclic aromatic hydrocarbons, nitriles, and traces of metals that are rare in the outer crusts of natural planetary bodies. You have to ask yourself, why does an interstellar object possess the chemical recipe for life? This brings me to a concept that many in my field are uncomfortable discussing, but we must discuss it. Panspermia. The idea that Life is not a miracle unique to Earth, but a contagion that spreads from star to star. Imagine 3I Atlas not as a rock, but as a cargo ship, a frozen, drifting vessel carrying the biological precursors, the amino acids, the building blocks necessary to jumpstart life in a new system. We found nitrogen-bearing compounds on the surface. These are essential for biology as we know it. If 3I Atlas crashes into a young planet or even passes through a protoplanetary disk, it seeds that system with a potential for life. We might be looking at our own history here. Earth may have been seeded by a visitor just like this one billions of years ago. It forces us to reconsider our place in the cosmos. We act as if we are the landlords of the universe, but perhaps we are merely the tenants who moved in after the previous occupants left their furniture behind. Let's dig deeper into the physical structure, because this is where the natural explanation begins to fray at the edges. The density of 3I Atlas is perplexing. Based on its size and its gravitational influence on nearby test particles, it appears to be incredibly dense, yet its rotation suggests a mass distribution that is wrong. In a solid planetoid, mass is usually concentrated in the core, but the rotational dynamics of Atlas hint that the mass might be distributed toward the shell, or that the interior possesses vast caverns. Now, I want you to suspend your prejudice for a moment. In science, we often apply what we call Occam's razor. The simplest explanation is usually the correct one. But what is simple about a moon-sized object, ejected at high velocity, loaded with refined metals and organic compounds, tumbling with a hollow density signature? Could it be artificial? I know. Whenever I use that word, people get nervous. They want me to say rock. They want me to say ice. But we must follow the evidence, not the social pressure. If an ancient civilization built a megastructure, a Dyson sphere component, a massive space station, or a generation ship, and that civilization died out, or their star system was destroyed, what happens to their technology? It doesn't disappear. It becomes space junk. Think about the Voyager spacecraft we launched. It will drift through the Milky Way for billions of years. To an alien astronomer a billion years from now, Voyager will just be a weirdly shaped piece of metal. 3I Atlas could be the Voyager of a civilization that existed 5 billion years ago. The high albedo, the metallic spectral lines, the hollow density, these are consistent with a derelict technological object. It might be a dead shell battered by cosmic rays for eons, but the structure remains. We are acting like a primitive tribe, finding a smartphone on the beach and assuming it is just a shiny rock because we have never seen technology before. We must stop being that tribe. We must be the adults in the room who are willing to say, this does not fit the natural model. What is particularly striking to me is the surface temperature. Webb detected hotspots, localized areas where the object is radiating more heat than it should be, simply from reflecting the sun. If this were a dead rock, the temperature should be uniform. These thermal anomalies suggest that something inside is retaining heat or perhaps generating it. Could it be radiogenic heating from a rocky core? Possibly. That is the safe answer. But could it be the fading remnants of a power source, or the thermal signature of different materials, insulators and conductors, arranged in a non-natural pattern? We cannot rule it out. And to rule it out simply because it sounds like science fiction is bad science. The implications of 3I Atlas go far beyond astronomy. They touch on philosophy, on theology, on the very core of what it means to be human. If this is a natural object, a shard of a destroyed planet, it tells us that the galaxy is a violent, chaotic place where worlds are ground to dust and scattered to the winds. It tells us that our own Earth is fragile. We are floating in a shooting gallery, and the floor is littered with the bullets that missed us. But if it is artificial, If this is a relic, then the silence of the night sky is a lie. It would mean we are not the first. It would mean that civilizations rise, build great things, and then perish, leaving their monuments to drift in the dark. It is a sobering thought. It reminds me of the poem Ozymandias. Look on my works, ye mighty, and despair. 3I Atlas might be the Ozymandias of the stars. I want you to consider the timeline here. The universe is 13.8 billion years old. The Earth is only 4.5 billion years old. That leaves a gap of over 9 billion years before we even showed up. Imagine how many civilizations could have risen in that time. Imagine how much debris they generated. And statistically, it is almost impossible that we are the first to launch metal into space. The fact that we haven't seen it before is likely because we weren't looking, or we didn't have the eyes like the James Webb Telescope sharp enough to see it. Shutterstock. We are now entering a new era of space archaeology. We are no longer just looking for microbes on Mars. We are looking for the artifacts of the Milky Way. The trajectory of 3I Atlas is also fascinating. It is moving fast, too fast to be bound to the sun. It is just passing through. This brings up a concept I have championed with the Galileo project, the idea of interception. Right now, 3I Atlas is too fast and too far for us to catch with our current rockets. We are watching it sail away into the dark, but its existence is a wake-up call. We need to be ready for the next one. We need a mission on the launch pad waiting when the next visitor comes, and the statistics say there are quadrillions of them. We cannot just take pictures from a distance. We need to land on it. We need to drill into it. We need to see if that rock is made of alloy. Imagine the moment a probe touches down on the surface of a visitor like Atlas. Imagine the camera panning down to the soil. Do we see regolith or do we see a hull? The difference between those two images is the difference between being alone in the dark and being part of a crowded ancient community. There is a resistance in the scientific community to these ideas. I face it every day. There is a desire to keep the universe boring, to keep it predictable. When I suggest that Oumuamua or 3I Atlas could be artificial, my colleagues say, Avi, that is extraordinary claims requiring extraordinary evidence. And I agree, but we must actually look for the evidence. We cannot close our eyes and say, I see no evidence. That is not skepticism, that is ignorance. The data from Webb regarding the isotopes on 3I Atlas is another smoking gun we need to discuss. The oxygen and carbon ratios are distinct from anything in our solar system. This confirms it is an alien visitor. But more importantly, the specific isotopic mixture suggests it came from a star system with a much higher metallicity than our sun, perhaps an older system, or one in a dense galactic neighborhood. This object has traveled light years to get here. It has survived the freezing cold of the void, the bombardment of cosmic rays, and the gravitational shearing of passing stars. It is resilient. If it is a natural planetary core, it teaches us that planets are tough survivors. If it is artificial, it teaches us that technology can outlive its creators. I want to leave you with a thought about the future. What happens next? 3I. Atlas is heading back out into interstellar space. We will track it until it fades from the view of even our most powerful telescopes. But it has left a mark on us. It has proven that the monsters in the dark are real monsters of rock and metal, giants that defy our understanding. We are currently building the Vera C Rubin Observatory in Chile. Soon it will come online. It will survey the entire southern sky every few nights. I predict that once it is operational, we will find that objects like 3I Atlas are not rare. We will find that the solar system is swarming with interstellar visitors. We are like a family living in a house with the windows painted black. We think we are alone. But once we scratch the paint off the glass, once we turn on the Rubin Observatory, once we launch the next generation of space telescopes, we will see the traffic on the street outside. And when we do, we must be brave enough to accept what we see. If we find that the street is full of rocks, fine, we learn about planetary formation. But if we find that the street is full of debris from other civilizations, spent stages, broken probes, mirrors from solar sails, we must not turn away. We must not be afraid of the answer. The discovery of the true scale of 3I, Atlas is a humiliation for our ego, but a triumph for our curiosity. It reminds us that we are small, but it also reminds us that we are capable of understanding the vastness. We are the universe observing itself, and for the first time in human history, we are seeing the other players on the stage. So the next time you look up at the night sky, do not look at it as a static painting. Look at it as an ocean full of currents, full of drifting wreckage, full of stories waiting to be told. 3I. Atlas is just one bottle that washed up on our shore. There are millions more out there, and I for one intend to find them, to read the messages they carry, and to understand our place in this magnificent, terrifying, and beautiful cosmos. I'm Avi Loeb. Keep looking up and stay curious.